Awesome. All right, so we have an ERC20 sample contract that is part of the repo under here's the ERC20 smart contract here. And then the logic, I guess it needs two specific, two contracts to make it work. And so that's the contract we'll be interfacing with today and working with. In order to work with the contract, you need a few things. You need some keys, key 1, key 2, key 3. You need to fund key 1 and key 2, actually, we discovered, because key 2 will need to pay for a transfer. So we got to pay, you got to fund key 1 and key 2. We'll use the DevNet today. Makes things a lot simpler. You don't have to worry about running a node locally. Of course, you could always run this on a node. And then we'll use the CasperLabs client using, you want to install that using brew, app, Docker, or tarball. Of course, you can have the Python client as well. And then we've got some scripts in the hack Docker folder that Maciek has written for us. There's a script called ERC20.sh in the scripts directory. And we'll run through the commands it supports. And he's just did this for simplicity. It's super easy to work with the scripts, and then we can dig into the scripts and see what the scripts do. All right, so first thing to note is that you want to have some keys. You appear to have plenty. And I have to see which one. I'm going to take a quick peek here and see which one Tom, it was test 2 and test 3 that we deployed the contract against, right? I'm going to use my test account.
We used definitely test 2, I believe.
Okay. Yeah.
And test 3, and we used Meta's cool account, maybe.
Mm-hmm. Okay. All right. So I'm going to use my test account because I don't think I've deployed it against that, but let me just validate that. So what I'm doing right now is I'm going into Clarity, and I just want to validate whether I've already deployed a token contract, because I've run through and tested these before. So I'm just going to validate. Okay, I do not have a token contract against that contract. So that's good. So I can go ahead and use this account. So I'm going to use my test account for the purposes of this. All right. So let's get started. So the first thing we need to do is just get the latest version, either do a Git Pull or a Git clone. And I'm up to date with dev, so I don't need to pull anything. We're working off of the dev branch today. And then we'll want to go in and compile the contracts. So I'm going to do make build contract.rs ERC20. This will not autocomplete, so you'll just have to type it up. Okay. Now I'm going to do the exports. It's the private key, and I'm going to export the public key, and that's going to be, I'm just going to grab it from here. It's this string here. Stranger danger.
Crazy dogs.
Stranger danger. Okay. And then if you're using the Python client, you can skip the step. Otherwise, export the location of the client. I'm going to do that. I'm going to export it because I'm using the Scala client. CL_client equals CasperLabs -client. The scripts do expect that it's looking for the CL_client parameter. So if you don't use that, you'll get an error that it can't find the client when you run the scripts. And so now that we've built the contracts, we're going to hop back over to Docker hack, or hack Docker, sorry. If you do a quick ls here, you'll see that you see this ERC20.sh script. I haven't had my tea yet. I can see that. All right. So if you just run ./ERC20.sh, you'll see all the commands that this little script supports. And so it starts with deploy, right? So deploy, it basically deploys the ERC20 smart contract with the initial amount of tokens. And it's deployed against the account associated with the private key that's provided. And then later on, you'll refer to this ERC20 token contract with the host address, which will be the public key, right? So that's the address of the account of the contract that's later referenced. So you'll see later on, we go through, we'll do a variety of different functions with the token contract once you've deployed it. And you'll see this contract host address requirement, right? And that's the address of the account, which is the public reference associated with the private key. So there's deploy, there's balance, which is just the balance of the owner address, which is a public owner address, public key of the owner address of the ERC20 token contract associated with the host address. And then you can do a transfer from your account, contract host address, which means the token at the ERC20 contract, to the recipient address, which is their public key, and the amount. Approves, basically grants authorization for a sender to send a certain amount of token via transfer function from your account. So it's kind of like that whole key delegation. This is a function or feature of the ERC20. Allowance is the allowance granted, it's just a check, allowance granted in the approve function. So if I want to see how much somebody has approved me to transfer as a spender, that's what this allowance call allows, enables. Transfer from is how I can use this allowance to transfer from the account. Buy lets me buy more tokens for the token, for the ERC20 by using the native token CLX. And sell is the converse of that, sells them. And then help prints the message. And there are other exported bash variables that come with the shell script. And so you'll see the CL client, the CL host, deploy.casperlabs.io. We are using the DevNet. It's looking at the ERC20 WASM target destination. So if you have something different, then you'll have to update that. Token name is test_token. So you can rename your token by just updating this variable. And then auto propose is false and query deploy status false. So I wouldn't worry about those last two. So the first thing we're going to do is we're going to go ahead and deploy the token amount and token contract. And Thomas, if you want, you can absolutely do this. You should do this as well. You can play along.
I just did. I got a deployment hash.
Awesome.
I'm looking for it on the chain right now. Yeah.
Excellent. Perfect. Yeah, so if we go into blocks, looks like yours went through your deploy hash 69E3AD.
Yeah.
Yeah, looks like it went through. Clarity is slow to refresh for me.
Is there a way to get the stats of this deployment? I'm exploring the Clarity tabs right now.
You can do a CLI command with CasperLabs-client, and you can do show block and get the hash of the block, and you can get all the block details.
You can search the deploy too in Clarity.
Yeah, you can search the deploy too. If you click on the deploy hash, you'll get some details about it.
Yeah, I see.
Oh, did I get an authorization error with my keys again? I wonder. I don't think so. My deployment threshold and key management threshold is 1. Let's look here. I don't see a block. DE5. My test account.private key. That's right. There's money in it. Why did that not work? Oh, I know why. I know exactly why.
You have those, brackets around it.
That's why. Now this will work. I need to have more tea. Tom, I'm striking out this morning. What did I do?
I would try using clean keys.
Oh, no, I checked my keys. My keys are fine. Oh, man. Okay. All right, let's use another key. My keys are clean. Let's see if I've got the token transfer, big token contract. Not there, this one. Okay. All right. Let's do this. What do we decide on? All right, let's try that again.
I don't see it.
I don't see it either.
Did you do a Git Pull meta from the update that I ended yesterday?
Oh, let me check here. Back.
No, you can do it there.
Can I?
Yeah.
Seems that must have been the problem here. There's a few files that changed.
Yeah, I don't see the one I changed there. So you must have already had it. Unless they all didn't print, which is possible. You can VI the script to make sure you have the right one.
Didn't I change it locally?
You did, yeah. It's true. Yep, so it's got the underscore. So that's correct. Log in into all these boxes. And do you have the deploy hash?
Yeah.
See what you're getting denied for.
Hold up, I'll send it to you in the. I'll send it to you in Slack. That's really weird. Thomas, I swear we did this yesterday and it worked fine. I don't know what's wrong. I'm glad it's working for you. I'm glad it worked for you. I mean, we can proceed. You can just keep going through the tutorial.
That's strange. So the files that I see are that have been updated with the poll, I had about like 2 or 3 times as many. So maybe there's I don't know.
We did find a small bug in the scripts, which we fixed yesterday. That's what he was looking for.
Yeah, I'm poking around in that file right now.
Yeah, go and take a look at it. You can see how it works.
So the one you sent me had the weird brackets. Do you have another deploy hash meta?
That's the last one I sent.
Yeah, it says for input string, and it has the brackets around 5555555.
Weird. Okay, let me try the deploy again, see what happens. Okay, 39DD 04 ADC.
Oh, there it is.
There it goes. That was weird.
Yay.
Yeah, that one looks good over here.
Great, good. Okay. So if we go into the DAG slice here, get the latest block in GraphQL, we can query the global state. Make sure you have the right account. And you put your address in there. And then when you run that query, oh, I had to use a different one. This one here. You run that query, you should see two contracts. So you'll see the ERC20 proxy name, and you'll see the test token. Okay, there's 2 contracts in there. All right, so moving along. So now you can check the balance in the token contract. So if you do ./ERC20 sh balance, $pub, $1 pub is meant for the address of the account. The other one is the holder, right? And so in this case, they're both the same.
Nice.
And so the expected result is that you'll get the same number as you got in your deploy command. And so now we can do a token transfer to key number 2, and we just need the public hex for key number 2. So you can pick another key if you want to see it within Clarity.
Needs to be a funded key meta.
Oh yeah, key number 2.
Well, I'm not seeing my cap in GraphQL. Should I?
You're not seeing your what?
The cap, the token cap of, I put 500,000.
Yeah, the token amounts, right? You
No.
won't see the token amount in there because we have this purse model, and it's stored in its internal data, internal to the contract. So you have to use the balance call from the command line.
Okay, that makes sense. Okay.
We're going to work on including that. Thank you, Tom. I will make sure it's funded. So we'll use my test 3. So using my test 3.
Oh, there's a balance call in here.
Yep. There's a balance call in there. Yep. I wonder if with my test 3, I'm going to get a different result though. Well, we'll see. Because it may actually, I wonder if it'll treat the token differently. All right, let's see here. Always learning. So now we do /ERC20 sh transfer $. 100. Here we go. Looks good. Now we will go and check the balance at key 2.
Host public hex is the matching public key for the ascender's private key.
Host public hex, yes, hex, yes.
Okay, that's what I thought.
And the address of the ERC20 token if that's what you use to deploy it.
Gotcha.
Oops. There we go, 100 tokens. So we transferred, we checked the balance, and now we know key 2 has 100 tokens. And so now we're gonna authorize key 2 to transfer some amount of token. So we're gonna do ERC20.sh approve.
So this public key becomes the contract address?
That's right, yeah, because the contract is stored under that account at that address. Right, so if you look
Gotcha,
here,
okay.
right, this is the public address for the account, and these are the named keys, and that's how it looks it up.
Gotcha, okay.
Now, the cool thing is because we have this associated keys feature, you can also enable another key to sign on behalf of this account, which is what the approve feature does.
Right, right.
Which is what I'm doing right now. $pub, $key 2. And the amount authorized will be, I'll do $50. Let's do $50.
Good old ERC20.
Yeah. I suspect we'll be able to add additional interesting features to a token standard, but we wanted to start small, crawl, walk, run. So we started with ERC20, and here's my block. This block approves key 2 to transfer 50 token. So now we're going to use key 2 to transfer token to key 3. We need to make sure key 2 is funded with tokens from the faucet, and you will assign this transaction with the private key for key 2. So we're going to export key 3. And this is going to be an account that is just going to receive some token. It need not have any token in it. So I'm going to take one that has no token in it. That's key 3. And then we're going to go back here. I need to export key 2. And now I need to keep it straight. B131. My test 3. Okay. Export. Private key for key 2 equals. Okay, so now we're going to do the transfer from. So /.erc20.sh transfer from capital F dollar to signing the transaction dollar $PUB, which is the contract address, key 3, which is the destination address, and then some amount smaller than the authorized amount. So we're just going to do 15 token here. Unbound variable. What did I do? What did I do wrong here? I think I need pub2 in here twice, don't I? Do we? I think there's a typo here.
You can do a help to verify.
Yes, owner address.
Yep.
Can you put the change in that doc there? Catch
Yeah.
that mistake, because that was the one thing I forgot to fix. So you need the contract address and the owner address because anybody could authorize you to send. So. There we go, got a hash. See if we get a block. There we go. Looks good. And so now if I go into Clarity, I won't see that transfer because it's not CLX tokens. So now you have to just go and do the balance at key 3. Right, so we do ERC20.sh balance. $pub tells the system what token to look for. Key 3 tells the address to check. There you go, 15 tokens. And so now if we want, we can buy more tokens using CLX tokens. So we can do .erc20.sh buy Now, Thomas, I can also send you token and you can send me token if you wish, right? So like you can grab one of my public keys and just send me some token. And I can grab one of your public keys and send you some token.
All right. I'm actually, something weird is going on.
Okay.
Oh, share your screen.
All right, hold on 1 second.
Okay.
Yeah.
All right, so we're going to focus on.
Okay. That's weird. It's gone now. I don't know what the problem is. I'm trying to figure out what the problem was.
What happened?
I'll show you anyways. Here, let me figure out if I can. That's the one right there. Okay, so I went to go check the balance right here the first time. account has this many tokens. And so I went to go transfer. I guess the hash didn't go through the first time when I did the transfer the first time. I'm not sure.
Huh, that's weird.
Yeah,
But you
I
did
mean, it's showing it
balance.
correctly now.
Okay, okay, got it. Okay.
But I'm trying to figure out what that was right there. Yeah, weird.
That's
You
very
guys seeing
strange.
that?
No, I've not seen that. That looks like a bug somewhere in returning the data back from the global state.
Yeah. What I
And that
went and
happened
checked
twice.
though, this net. Yeah, well, I just basically just hit up tab and removed the quotes. Maybe that was the things, and tried it again.
Yeah.
But I went and looked for that hash. What was it? Where is it? Deployed with hash. I think it was this one right here.
Uh-huh.
And that doesn't. I don't think this exists anywhere. Let me look again.
88C, so when you search for it, you search for your public key.
Yeah, it never actually went through. So I guess it returns this when it doesn't have a balance.
How are the meetings going over there regarding funds?
Maybe. That's a bug. Bug in the script.
Huh. Well, it's working now. I guess it just didn't go through the first time. So.
Oh, but then you did the balance
that-
later, and then that worked.
That's because I did the transfer again right here and got a new deployment hash, which is right here.
No, but you did it above, and it said 5,000 or 50,000, 500,000 tokens.
I went and checked the contract. Let me check the.
So you checked the contract. Okay.
Let me check the contract again.
Oh, AAC 3127.
Yeah, that's right. Okay. Well, it's working now.
Strange. Okay, it may have been that it was empty. But we'll test that for sure and see if we get that same error.
All right.
Cool. Yeah, so then you can actually buy tokens with the contract as well, and then sell tokens, for CLX. You need to make sure that the account that's buying, of course, is funded and selling, because this is using sender pays. So it's using the standard payment code. It's not using custom payment code. So yeah, then you can play with that a little bit and go through the script and take a look at the script. Yeah, and take a look at the script to see what the script is. Yeah, so that's the little ERC20 contract. So pretty simple, straightforward. Is there anything I can help you with? Do you have any questions? Anything you want to see in the system? You've got Tom and Mark here. We've got a few folks from CasperLabs here on the line that can potentially help you out if you have questions.
Yeah, there was. Yeah, I saw you basically went through. I missed a little bit of it, like the approvals. I mean, I got most of it, but that's basically. I mean, you basically covered all the basic ERC20 components there. That's awesome.
Mm-hmm. Yeah. Yep, exactly. And yeah, you feel free to take a look at the contract itself in detail. I think if you look at the smart contract itself, the logic.
Where's that actually located?
Let me share my
That's
screen.
not this shell script here.
No, it's not. You can see it in GitHub. It's in GitHub. So if you go into GitHub, you go to Execution Engine Contracts Example, you'll see the ERC20 logic, and you'll see the lib.rs. This is the actual contract.
Contracts.
Yep, contracts, example.
Example. I'm working on ERC20 logic or smart contract.
Yep.
What is this logic? Yeah. Are you in the cargo file, or is this the?
I'm in the lib.rs under source.
Let's see. Okay. I think I remember this a little. I think I remember going over this a little bit with someone.
Someone from the team? Okay.
Yeah.
Yes, you see all the functions in here for the core logic of the ERC20 token. So you can definitely go through that and play with it on your local. And then in the examples, we have other contracts too. So we've got a keys manager that we just created. We've got a mailing list. We've got a vesting smart contract too, which simulates a stock option grant. So we're going to be putting some documentation in there for the vesting logic and the vesting smart contract as well.
Oh,
And then
cool.
we've got a cute little
Yeah.
counter call and counter define logics.
Hey, Meta, did you
I
get
remember that one.
Meta, did you get the balance query?
Uh-huh. I got to, you want me to do the last balance?
No, I did that. I'm getting some error. It says validation failure for key option parameters.
Okay, share your screen and then Tom can walk you
Let
through it.
me- Let me share my screen. Can you guys see my screen?
Yeah, it's coming through.
Hide this. So you see the last one?
You have to scroll up again. Hit the
Okay,
return a few times because we can't see the bottom. Zoom is like terrible.
There you
It
go.
cuts it
There
off.
you go. Yeah, there you go.
There we go. Yep.
It says error validation failure for key.
Can
Oh,
you
because-
echo? Go ahead.
No, but you've got the public key there. You need the private key.
Yeah.
This $pub should be $private. I mean, on your
I don't think
document-
pub.
No.
I don't think pub can take a file path. I think pub needs to take the actual string.
So here is, this is what in the document, right? You can check the value. I could get through all of this. I got the GraphQL.
Can you echo pub? Echo $pub?
I think you need to cat it.
No, echo will work.
No. I mean, when you do that.
public key.
Yeah,
Right,
so
he
it's the
needs to
public
cat.
key string. It is not the path.
So when you export it, you got to cat the path, and then it'll put the file, the contents of the file in there. It doesn't take the file path there. It only takes the file path for private keys.
So I have to do cat here.
No, so what?
No.
Wait, just do export pub dollar. Just export pub no dollar equals, and then the string to your public key that you can get from Clarity. That's the quickest, simplest way.
Export.
Dollar,
Pub.
just pub.
Hmm.
Set that equal to your public key string, which is in Clarity.
Oh, okay, got
You're being too high tech.
it. Okay. Okay,
Okay.
and then I can do the same
Now the balance should work.
$pub.
Mm-hmm.
Mm-hmm. There you go.
Yep.
That's it.
Oh, fantastic.
I'll update the documents to indicate that it should just be the string from Clarity, so it's clear.
It's
Yeah.
already there.
Is it? Oh.
Export
yeah, it does say-
public key string from Clarity.
Where is that?
Right there. In the document, it does lay it out.
It says we can now check balance or token balance. Okay.
Terrific.
Fantastic.
I haven't seen many occurrences where you guys call for the base 64 or the file public key. So every time a public key is called, it's 99% of the time going to be the hex version, right?
Yeah.
I still haven't yet to see the.
No, we're
the
actually
other
going to
version
remove.
we
We're going to
called.
remove the base 64 from Clarity altogether because I think it just creates confusion, and it's on the left-hand column as well. So we're just going to remove it because we don't use base 64. I don't think for anything, Tom. Right? We cleared that up. I don't think base 64.
only
We'll have
thing
to go
that-
through.
There was one.
Yeah.
Yeah, there was one thing I think last week we went over where we were printing base 64 strings in quotes on the terminal. I think.
I think
For
there's like
for
one
one
nit.
thing, but
There's one spot where it's left that we need to pull it out. Yes.
so you guys plan on by the time production starts, or, you know that it'll be all big hex.
It'll be all hex, yeah, for simplicity. Yeah, I don't see any point in
simplicity,
confusing.
right.
Yeah, confusing people with multiple variants of the same key. So it'll all be hex by the time we go to production. I mean, even sooner than that, before we go to testnet. Assembly script support is coming in a couple weeks. So when you do your contracts build, you'll see some stuff here for NPM, which is what we use to build the assembly script contracts. So that's coming in.
Am I able to build one right now, or are you guys just building kind of a user-friendly thing where you can just NPM it and then be done?
We're still working on that. Yeah, we're building that, and we're building like
okay.
the contract library too for assembly script support. So you can build contracts now. Don't have to use
am I
Rust.
still projecting for some reason?
You might be. I don't know.
Yeah, you're sharing stuff.
Yeah, you're still
Okay.
sharing.
All right.
There you go. Yeah, so the assembly script stuff will be coming, and then you can write contracts in assembly script. You don't have to use Rust if you prefer to use something that's more like a JavaScript script type library. Will have support for that.
So who's just a quick question? These lib.rs files in the ERC20 logic folder, I'm just kind of poking through right now. I would. I wish there were comments in here like this does this, this line does this.
We're going to work on that. We're going to work on that. There's we have tickets in place to get it more documented, as well as providing a DApp developer guide that'll provide more information on what each of the calls do. So
Gotcha. I'm not being nitpicky. I'm anxious to learn. You know.
No, 100%. So Ashok, can you just add an action item to follow up on that, and make sure we get real detailed documentation in those contracts?
Okay.
It should take very long to do inline documentation and comments. Terrific. Great.
Cool.
We will definitely get you more information on the contracts themselves. And thanks for joining. Appreciate it. It's always good to chat with you, Thomas.
Thank you very much.
All right. Have a great day, folks. Cheers.